In this video, I introduce a Deepercluster for unsupervised pre-training on non-curated data. Deepercluster combines self-supervised learning and clustering to learn visual representations from unlabeled and non-curated data. Given a set of images from x1 to xn, a pseudo-label yn is assigned to input xn. Self-supervised learning trains the network f theta, as shown here, by solving this minimum problem, where v is a linear classifier and L is a loss function that is used to jointly train the network f theta and the classifier v. The pretext task is defined as a rotation in 0, 90, 180, and 270, as shown here. Clustering generates target classes using the features generated by the network f theta, and the targets are updated during training. A latent pseudo-label Zn is defined for each image n, and its linear classifier is W. Clustering alternates between learning the parameters theta and W and updating the pseudo-labels Zn. The parameter theta and the classifier W are optimized by solving this minimum problem, where we use k-means in latent space to update targets. We can use Cartesian product space to capture intersections between the self-supervised learning and clustering defined here. It makes a decision over full vocabulary, and therefore it doesn't scale in the number of combined targets. Deepercluster uses a hierarchy of decisions to solve this problem, each with a smaller space. The target labels are partitioned into super and sub-level, as shown here and here. Deepercluster first predict the class of input in the super level and then in the sub-level. The super class level partitions the image into S classes, and Yn denotes the superclass assignment of the image n. The subclass level is obtained by partitioning each superclass, which assigns Yns to the S entry of Yn. The superclasses are predicted by a linear classifier V using the features as inputs. The subclasses are predicted by S linear classifiers from W1 to Ws. The linear classifiers V and W and the network f theta are trained by minimizing the hierarchical loss function defined as here, where Zns is a vector of assignment into Ks subclasses for image n belonging to a superclass S, and L is a negative log softmax loss function. Deepercluster splits the dataset into M sets by running k-means with M centroids on the full dataset every t epochs, and uses the Cartesian product between the assignments to the M clusters and the angle rotation classes to form the superclasses. Therefore, M superclasses each associated with a subset of data belongs to the corresponding cluster. These subsets are then further split with k-means into k subclasses. Every t epochs, Deepercluster recomputes the super and subclass assignments by running two consecutive key means on the entire data set. For more details, please check with these references. Thank you. Bye.